Okay, exercise 1.02 question 3, it asks for the distance of a certain point, in this case, negative 724, from the origin. When it means the origin, it means that if I was to draw this up as a series of coordinates on a plane, the origin is this thing here, and the coordinates of the origin are 0, 0. In this case, it's negative 724. Now, I really can't draw this to scale particularly easily, but let's say this tiny little bit here is negative 7, which makes the distance from the origin 7 units. So that distance there is 7. That point is 7, negative 7. And let's make 24 up here. So that's 24 there. So in other words, really the point there is negative 7, 24. And this point here is negative, sorry, it's 24. So what we're really after, and I'll try and draw this so it roughly hits there. Good, all right. That's the distance we're after. How long is that line? Now, of course, we could just use Pythagoras to get that, because this length is 24, this length is 7. I'll draw it like a triangle here. We know this is a right angle triangle. We could just say, well, let's call the long side a. Well, we know that a squared is equal to b squared plus c squared, according to Pythagoras. And we can go ahead and solve that straight away. So a squared is equal to b squared plus c squared. I'll restate it. So a is equal to the square root of b squared. Well, b, and let's call b this thing here, 24. So it's 24 squared plus c squared. Now, c squared, we're going to make this bit along here. We're going to call that c there, and this bit b. So c is going to be 7 because it's the distance. It's not the negative, but it's not the coordinate. It's not the point on the graph. It's how far that point is from the origin. So a then is going to equal, well, 24 squared. That would be and 7 squared, we know, is 49. All right, the two together would make 625. Now, the moment I see 625, I think, right, oh, that's 25 squared. So that's a nice straightforward thing. So I can just say A is equal to 25. Now, looking at the question, it doesn't ask for units. It doesn't say it's in meters or kilometers or anything. So I'm actually going to write some units in, and I'm just going to write 25 units. Now that, of course, is just using Pythag. I think the common sense approach like that is perfectly fine. If you use the approach which coordinate geometry dictates one should use, then you're going to go differently. You're going to say, well, d squared. Well, let's use the coordinate geometry approach. I'll write it over here. So we've got d squared is equal to the square root of. Now, remember, it is Pythagoras. It's exactly the same thing, but it's kind of a simplistic version, just to even if you weren't quite sure what to do, you just throw in the numbers and you end up with the result, which is fine, but I think we need to be more intuitive than that. But nonetheless, let's try it. X squared minus x1 all squared plus y2 minus y1 all squared. Well, let's designate some values for this x2 and x1. So let's say, well, 0, 0 is one of our points. Let's call that x1 and y1. And let's say the other point, which was negative 7, 24, let's say that x2 and y2. Now let's substitute those values into the equation. So we're going to have the square root of, let's make some more room on the desk here. X2 is, what was x2? Yes, minus 7, so I've got negative 7 minus, well, x1 is 0, and I'm going to square all that and add to it. Y2, well, y2 is 24, and then subtract from that y1, which was a 0, make that a bit longer, and square it. And we land in exactly the same place, because negative 7 squared is 49, plus 24 squared was, what did we get before? 576. So 576, and of course, that gives us root 625, which is 25 units. So two different ways of getting to the same place. Both are perfectly fine, but just remember, think intuitively about what you're doing. But a great question. Thank you.